Okay, just a short update video. I made my new transformer. It's tiny, as you can see on my finger. I've been running some little tests on it. I basically, there's a ruler, so you can see roughly, it's about 50 millimeters long. I tried a few different coils. I tried these little coils with the ferrite cores in them. I also tried double coils, stacked, and I actually ended up using some coils like this, but with a ferrite core in the middle. So these are the secondaries, and I also had to cut some ferrite transformer cores in half and into quarters. Actually, it's the quarter ferrite sections that form these little bits here. That couple the actuator coils with the secondary coils, which are these two secondaries. These are actuator coils, and there's a Alnico magnet between these actuator coils. So there's actually you can't really see it 'cause it's inside the actuator coil. But yeah, anyway, as you can see, my LED is really, really, really bright. So we're getting somewhere. At the moment, I'm actually only pulsing it. I'm pulsing it at 80 microseconds at 45 volts, 45 volts, and I'm pulsing it with the. And my oscilloscope is it's at 265 hertz. 60 microseconds pulse width. We don't really need to worry about the voltage because that's just a driver I'm monitoring. But the frequency on the output is kind of interesting because it's not quite what I'm putting in. It's different. And the maximum voltage is 11.6, peak to peak 20.8 volts. Pulse width is actually higher, probably due to the fact that the waveform's being compressed by the load. And that's my output waveform, and that's my trigger pulses. You don't have to worry about those because, as I say, they're not actually on. I'm not measuring the actual input voltages, and that's the trigger output. That's the output. So on the scope, so I don't know if you had got any of that because, anyway, I'm full of cold at the moment. I didn't feel like doing a lot, but I had me working on a bigger one. Well, the bigger one's on top of the laptop over there. I haven't bothered building it yet because I thought, well, I'm going to play around with something smaller because I can. The main reason for using something smaller is because I can use the small ferrites, and I've got I've got a bag of those actually from China. I've got a great big bag. I think they sent me about 50 toroidal cores, so I've got plenty of those to play with. So I thought, well, let's use those, and these are what I cut. So obviously I use a diamond cutting thing, so they're not quite round anymore because I cut them in half. The way to get them cut exactly in half is I actually 3D printed these little things, and that way I've got a saw guide. So I put the toroids inside this little toroid holder, and it holds the toroids perfectly still, and then I can use my diamond cutting wheel through the slots and perfectly cut them down the middle and quarter them into quarters as well. So instead of having to fart about trying to get a straight line and trying to mark the ferrite off with a marker or something, it's what you call in engineering terms as it's called a jig. So I'll just put my ferrite toroids in there, and then I'll cut them. So I just went in the other room just to get you a toy to show you. These are the ones. These are the ones I got from China. Actually, they sent me a big bag of them, and some of them were broken. So rather than wasting all the good ones, I actually cut some of the broken ones into quarters. I had a few quarters left over, you see, so I thought, well, why not make use of those? I'll show you. Hang on a sec. Right, here's my. I made a slimline. It's a bit shorter because it's easy to manage. So I'll just get my toroid and pop it in like that, and now it's ready to cut through the gaps. And it's a snug fit, so it doesn't move around. It won't fall out unless I use a magnet to pull it out. And then I can just use my diamond cutting wheel and cut them. So yeah, I have to do it in water though because it makes such a mess. And no, I've not measured the current consumption of this yet, but for the first time, all of the LEDs are lit up anyway, let's put it that way, and I'm driving the circuit. This thing is currently being driven at about 150 milliamps, so, but, yeah, I've no idea. Well, we're not there yet. You know, there's lots more experimentation to do. I actually want to make a bigger one. What I was thinking of doing was stacking some of these ferrite cores on top of each other and to thicken it out to make it a bit bigger, and then I can do a much more realistic larger scale test. Obviously there I can use just one input circuit and should be able to get more output out. That is the theory, because at the moment it is kind of, well, it's all proportional. The more ferrite that there is, then the more inductance I'll be able to carry through generally. At the moment, the ferrites, well, they're quite thin really in proportion. And anyway, enough of that, because I'm not, as I say, my voice is not very good because of this cold and sniffing and sore throat. So anyway, thank you for watching.